Hello, welcome back to Maths and Science Professor channel. We are still looking at computer numbering systems, and today we are looking at hexadecimal system, and we will look at how you can convert hexadecimal numbers to decimal numbers. And first, you need to familiarize yourself with these hexadecimal numbers. We have 1 to F. We have 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Now, the numbers run from 0 to 9, and then 10 is represented by A B is a representation of 11, and so on and so forth up to F, which is a representation of 15. Now, these are the hexadecimal numbers. You can be given numbers in hexadecimal and be required to convert them to decimal values. For example, number 1, E716. Now, these are hexadecimal numbers, and then you want to convert them to decimal. You take the first term, or the first digit, E, you multiply by 16 to the power of 1 plus 7 times 16 to the power of 0. The powers of 16 increase from right to left. They ascend from right to left. And so if you work out this one, E is our value for 14. It is 14 times 16 to power 1 plus 7 times 16 to power 0. And this will give us 224 plus 7, which is 231 to the base of 10. Let's look at the second example. Our second example, you have 2c to the base of 16. What you do is the same. You multiply 2 by 16 to base 1 plus c by 16 to base 0. 2 times 16 to base 1 is 32. And then c times 16 to base 0 is 12. And when you add all this, you have 44 to the base of 10. This is a decimal number. And the third example, we have 98 to base 16. 98 to base 16 is 9 times 16 to power 1 plus 8 times 16 to power 0. And this gives you 144 plus 8. You work out that you have 152 to base 10. So that's the procedure on how to convert hexadecimal numbers to decimal numbers. Let's look at how you can convert the second scenario. You want to convert decimal to hexadecimal. For example, 54. 54 is a decimal number, and we want to convert it into hexadecimal. What you do, you divide by 16 and you note the remainder. 54 divided by 16 is 3, and the remainder is 6. 3 divided by 16 is 0, and the remainder is 3. And then you take from the most significant bit to the least significant bit. We have 36 to the base of 10. That is 36 to the base of 16, which is now a hexadecimal number. Let's look at the second example. You have 200 to the base of 10. You do the same. You divide through by 16 and you note the remainder. 200 divided by 16 is a 12, and the remainder is 8. And then 12 divided by 16 is 0. The remainder is 12. So you have 12 and 8. 12 has value of C, 8 remain the same to the base of 16. Let's look at the last example, 91 to the base of 10. You will do the same. You divide through by 16, 91, and you note the remainder. 91 divided by 16, you have 5. The remainder here is 11. 5 divided by 16 is 0, and the remainder here is 5. Do take 5, 11, 5 remains the same. 5 and 11 is B to the base of 10. So this is basically how you convert decimal to hexadecimal. Let's look at the third scenario, whereby you want to convert binary to hexadecimal. First of all, it will be very important to know the different binary representation for different hexadecimal numbers. So we will have a table with a hexadecimal number, and a binary representation. Binary. For example, the first hexadecimal number, we have 0 and a binary representation of 0, 0, 0. Then we have 1, a binary representation of 0, 0, 0, 1. We have 2, a binary representation of 0, 0, 1, 0. We have 3, a binary representation of 0, 0, 1, 1. And then we have 4, a binary representation of 0, 1, 0, 0. We have 5, a binary representation of 0, 1, 0, 1. We have 6, a binary representation of 0, 1. We have 1, 0. 6 has a binary representation of 0, 1, 0. And then 7, a binary representation of 0, 1, 1, 1. To continue, 8 has a binary representation of 1, 0, 0, 0. And 9 has a binary representation of 1, 0, 0, 1. Hexadecimal number and binary representation. Now we continue from 9 to A. A has a representation of 1, 0, 1, 0. B has a representation of 1, 0, 1, 1. C has a representation of 1, 1, 0, 0. E has a representation of 1, 1, 1, 0. And finally, F has a representation of 1, 1, 1, 1. Now, if you have binary values and you want to convert them to hexadecimal numbers, you need to familiarize yourself with the different binary representations of different hexadecimal numbers. For example, if you have number 1, you have 1, 1, 0, 1, 0, 1, 1, 1. You simply separate or differentiate or find means of identifying the different binary values, which will give you different hexadecimal numbers. For example, in our case, we will have 1, 1, 0, 1, and 0, 1, 1, 1. Now you check what is the hexadecimal number or the hexadecimal value for the given binary value. In our case, 1, 1, 0, 1, 1, 1, 0, 1 is a D, and 0, 1, 1, 1 is 7. So this is D7 to the base of 16. The second example you have is 1, 1, 1, 0, and 1, 0, 1, 0. to the base of 2. This is a binary value. What you do is you differentiate 1110 and 1010. 1110 is E, and the other one 1010 is A to the base of 16. Let's look at the final example. You have 100 and 1011 to the base of 2. Differentiate, you have 100 1011, and you find out, turns out to be 8. This one turns out to be, from our table, this one turns out to be B to the base of 16. So this is how you convert binary values or binary numbers to hexadecimal numbering system. Let's have the fourth case where you want to convert hexadecimal to binary. You want to convert hexadecimal to binary. For example, number 1 is 37 to the base of 16. You just look, 3 is a hexadecimal number. What is the binary representation of 3? It is 0, 0, 1, 1. 16 is a hexadecimal number, or 7. What is the representation for 7? 0, 1, 1, 1 to the base of 2. Let's look at the second example. In our second example, we have ED. We have ED to the base of 16. E is 14 with the binary representation of 1, 1, 1, 0. D is 13, a binary representation of 1, 1, 0, 1 to the base of 2. Let's look at the last example, and our last example is 1, 0, 0, 0, 1, 0, 1, 1 to the base of 2. Now 1, 0, 0 is 8, and 1, 0, 1, 1, 1, 0, 1, 1 is B. 1, 0, 1, 1 is B to the base of 16. This is a binary value that has been converted to a decimal number.